Today, I can Newton.
And I, Captain Unatesh, is here to present our model of the CBSE Regional Science Expo on the theme Technology and AI Innovation. Our model name is the FalconEye System. These days, we can see many civil aviation accidents happening around the world. What is the reason? The main reason are bird strikes.
According to latest DGCA reports, Director General of Civil Aviation, there has been 1,500 bird strikes this year.
So, the FalconEye system calculates the bird's migration paths and configures the autopilot system using machine learning and Python programming to successfully evade birds and stop collisions in the future.
System. Every year, thousands of aircrafts around the world, including in India, suffer bird strikes. These bird collisions are not only a danger to human life, but also cause engine damage, emergency landings, flight delays, and huge financial losses. The idea for my project came from a simple question. Can we use artificial intelligence to predict and avoid bird collisions before they even happen? That's where FalconEye comes in. It's a system that combines AI-powered predictions with a real-time aviation simulator to show how aircraft can dynamically avoid birds, ensuring safer skies. Bird strikes are most likely to occur during takeoff and landing, especially at lower altitudes, typically below 3,000 feet. These often happen near airports surrounded by natural wetlands, fields, or garbage dumps, common bird habitats. Birds follow seasonal migration patterns influenced by climate, geography, and time of year. But aircraft don't always have access to this data in real time. My goal was to build a system that does two things: predicts bird presence based on past patterns and conditions, simulates real time aircraft response to detected bird threats. That's what FalconEye achieves through the power of machine learning and Python programming. The FalconEye system is divided into two major components. The first one is the predictive AI model, built using the Orange data mining software. This AI model uses past bird migration data and environmental features to predict the likelihood of bird presence in various zones. Second one is the evasion simulator. Designed in Python or Replit, this interactive simulator detects birds and dynamically moves the aircraft in the safest possible direction, demonstrating how AI decisions can guide real-time autopilot systems. Together, these two systems work as a virtual assistant for flight safety, warning pilots in advance and suggesting alternate motion paths when danger is near. In Orange, I imported a dataset containing regional zones: east, west, north, south, central, time of year, seasonal variation, weather factors, historical bird sightings. I used data visualization, train, test, split method, and classification models to train the system to predict bird presence in a specific zone at a given time. The result? The model gave strong predictions for most reasons, but with some variation. Let me explain that further. To strengthen accuracy and reliability, I experimented with two different AI models in Orange. The first one was the decision tree model. It performed extremely well in the east, north, south, and central zones. It's also highly interpretable. We can clearly see which rules and conditions lead to a specific prediction. However, it gave very poor results for the west zone, possibly due to less consistent training data or fewer bird records in that area. My second model was the random forest model. My second model was the random forest model. A random forest combines multiple decision tree and averages their result. It delivered average yet balanced performance across all regions. It improved accuracy for west zone, although it wasn't as sharp in the east, north, or south as the decision tree. This experiment taught me an important lesson. Different models behave differently based on data patterns and regional dynamics. So I decided to include both models in my video to showcase how AI adapts to real world variability. One gives better clarity and the other offers better coverage. Now let us check the Python based evasion simulator. To demonstrate how aircraft might react in real time to bird threat, I built a visual simulator using Python on Replit. Here's how it works. Randomly generated bird clusters enter the flight zone. If they come within a dangerous proximity, the autopilot takes control. The plane calculates the shortest safe direction and moves away from the birds. The display shows how many birds were detected by the thermal center simulated. After evasion is complete, the birds disappear and the aircraft returns to cruising altitude. This simulation offers a clear and engaging way to visualize how autopilot it simulates auto uh, simulates autopilot, control handoff, directional changes, and collision detection distance calculations. Through this, pro- through this project, I was able to Through this project, I was able to multiply 21st century skills, AI and machine learning using Orange, data science and model evaluation, Python programming and game logic real world problem solving, creative and critical thinking. I also learned how to evaluate model accuracy, interpret confusion matrices, and simulate user interactions with sensor based triggers. This has given me real insight into AI applications in aviation, a field where safety and innovation go hand in hand. FalconEye is just a prototype, but it demonstrates the real potential of AI in solving practical real world problems like bird strikes. With further data, government collaboration, and hardware integration, systems like FalconEye can be embedded in real airports and aircraft warning systems. This project helped me realize that technology, when applied meaningfully, can save lives, protect resources, and build a smarter future.
In conclusion, we would like to say that our model combines machine learning with Python programming to synthesize aircraft movements and track birds effectively. This model can save many lives in the future, especially near airports, near bird migration habitats. So, it's still a prototype model and we would like to develop it further in this CBSE Regional Science Expo. Thank you. Jai
Jai
Hind.
Hind.